Hello friends, here it is given ideal pump used to cool the house at inside temperature 20 degrees Celsius. It is given pump is doing the work at the rate of 1500 watt and it gaining the heat at the rate of 650 into inside temperature minus outside temperature watt per degree Celsius by conduction. In the first part, we have to find outside temperature for inside temperature to be constant. In second part, we have to find the time for which pump to be operated. If outside temperature is 8 degrees Celsius. Let us see here. First part, for constant temperature of inside, heat lost by the house must be equal to heat gain. Heat loss will be QL plus work done by the pump upon time interval is equal to 650 into heat gain due to conduction. So from here you may write QL plus W to be 650 into delta T. The efficiency of the engine is efficiency of the pump is defined as 1 minus T out upon T in, that is 1 minus QL upon QH, or it can be written as 1 minus QL upon QL plus W, that is W upon QL plus W. 1 minus T out upon T into B, W upon QL plus W. So from here we can write QL plus W to be equal to T in upon T in minus T out. Comparing equation 1 and 2, we will get 650 T inside temperature minus T outside temperature into delta T is equal to W into T inside temperature, T inside minus T outside. So it can be written as T out can be written as T in minus W T in upon delta T into 660. This is the power of pump. Substitute the value. T in is given 22, so it will be 295. Power in is 1500. 295 upon 650. On solving it, you will get 268 Kelvin or minus 4 degrees Celsius. This is the answer of part A. Now in part B, concept is the same. Heat lost is equal to heat gain. It is QL plus W upon delta T to be 650 upon T in minus T out. So calculate the value from here. This is 650 into 20 minus 8. So it is to be 9100 watt. From second equation, QL plus W upon delta T to be 9100. This is your third equation. From 2, we can write it is to be W upon T in upon delta T into T in minus T out to be 9100. So from here we will get W upon delta T to be 9100 T inside minus T outside upon T in. So it is to be T in 22 minus 8 upon 295. On solving it, it is to be 432 watt. Since maximum power of pump is 1500, since maximum power of pump is 1500 and it is required is 432, so percentage of time will be P upon P max into 100, 432 upon 1500, 29%. Time will increase by 29%. That's all. Thanks for watching it.